Alright, in this problem, we're going to take a bunch of congruent, regular pentagons and place them in a circle. And the question is, how many pentagons do we need to do that? Well, alright, let's look at a pentagon here. That's the first thing, because what we would really like to know is what are the angles involved with this pentagon. So let's take a look at one pentagon. And now, the some of the interior angles of a pentagon is something that I don't memorize. Most people don't have memorized. Maybe some people do. Now, for the interior angles of a triangle, I think we all know that. For a triangle, the interior angles add up to 180 degrees. So, if you don't have this memorized and you want to figure out what the sum of the interior angles are of this pentagon, let's break it into triangles, okay? And you can see I can break this pentagon into 3 triangles. So if I want to know the sum of the interior angles in the pentagon, I can take 180 degrees for each triangle, right? 180 degrees in each triangle. And if I add up all the angles of all the triangles, I'll get the sum of all the angles in the pentagon. So I'm just going to multiply this by 3. And you can see we're going to get 540 degrees. And so if it's a regular pentagon, I can take that 540 degrees and divide by 5 in order to get the one interior angle of a regular pentagon. Okay? Because in a regular pentagon, all the angles are equal. So we'll just divide this by 5. All right? And you can see that we get 108. So, these angles inside here are 108. Alright, this one here is also 108. This one here is also 108. 108. 108, okay? We can keep going around. They're all going to be 108 degrees. Alright, so how does that help us? Well, one thing is that you notice as we put these pentagons around this circle, we're going to end up inside, we're going to be making another polygon. And, you know, the type of polygon that we end up making is going to depend on how many pentagons we put around this circle, because the edges of the polygon in the middle are going to each have a pentagon on its side. So you can see the start of it is here. You know, we have this side, this side, this side, and we keep going around. And we don't know how many sides we're going to have. I'm just going to sketch in some, but you're going to have this n-gon, and so we just want to know what n is, right? So, there's actually a formula based on this idea that polygons can be broken up into triangles. So, like, for example, if I have a hexagon, hexagon has 6 sides, so let's draw a hexagon. 3, 4, let's see, 5, 6. Okay, that's not a very good hexagon. I should have drawn a better hexagon. I can draw better hexagons than that. Alright, so there's a hexagon. It's got 6 sides. And a hexagon, I can break that up into 4 triangles. Alright. If I had a septagon, has a 7-sided polygon, I could break that up into 5 triangles. Okay, so we can always break up any polygon into n-2 triangles. Okay, so the number of triangles we can break it up to is 2 less than the number of sides. So let's take a look at this n-gon that we were creating in the middle. All right. If we took 180 degrees for each triangle that we can break it up to, and we took it times n-2, alright? Because we have n sides in this polygon, and we can break it up into n-2 triangles. And then, if we divide that by the number of sides, because it's going to be a regular polygon, then we would get the interior angle of this polygon. Now we could figure out that interior angle because you can see here we got 108 degrees, 108 degrees, so we have 216 degrees. And so, and there's 360 degrees all the way around here. So, so what does this angle have to be right here, which is the interior angle of this n-gon we're creating in the middle? It's got to be a 360 minus, what is 216, right? So what does that give us? This becomes a 5. So we have 144 is this angle here on the interior of this polygon we're creating in the middle. So the interior angle of that interior polygon is 144 degrees. So really all we have to do is solve this equation and figure out what n is, and that'll tell us how many pentagons we have to place around this circle, to complete the circle. All right, so we can do that. Let's distribute this 180 inside the parentheses. So we have 180 n minus 360. Okay, and we can also multiply both sides by n. All right, that'll get the n off the bottom. So that's equal to 144 n. So we've got 180 n over here, and if we subtract 144 n from both sides, that moves everything and moves all the multiples of n over to one side. Right? So we end up with 36n, and then we can actually add 360 to both sides, and that'll move all the constant terms up to the other side. So we end up with 360 over here. And you can see when we divide both sides by 36, we get n is equal to 10. Alright? So that's our answer. N is equal to 10. So that's one way to do it. There's not, there's like any of these problems, there's multiple ways to do it. One thing is that you might be thinking about the exterior angles of this polygon in the middle. And you know that the exterior angles have to add up to 360 degrees. And you can imagine that, if you were a turtle walking along this polygon, you're walking along here, you're going along in the straight line, and then all of a sudden you have to turn by a certain number of degrees here, and then you follow that along, and then and you're going in a straight line, and then you have to turn by a certain number of degrees, and you do that so many times, and then you end up back where you started from, and you've completed a whole circle, so that's 360 degrees. So let's take a look at what this exterior angle is. Okay, so you have this turtle, you're walking along in a straight line across here. Now, we know this is 108 degrees, and we were walking along in the straight line, so that's 180 degrees. So this, and then let me redraw this because it's getting kind of messy. Okay, I'm going to draw this pentagon that I was working with before, as well as I can draw the pentagon, okay? So, and then I'm going to draw the other pentagon here. I'm drawing terrible pentagons here. Alright. So, there's two poorly drawn pentagons. Alright, I lost this. Okay, so there's two of my pentagons. Now the angle I'm looking for is the exterior angle. So I have to extend one of the sides out, and I'm looking for this angle here. I know this is 108, and this is a straight line, so that this angle plus this angle has to be 180, which leaves us 72 here, right? So there's 108 and 72, and I know that this whole thing here has to be 108, so our not 180, so our exterior angle ends up being, this is 108. Right, because that's the angle of the interior angle of the pentagon. Okay, so we're trying to find the exterior angle of this polygon here in the middle. All right, so the exterior angle is going to be 108 minus 72. All right, so what does that give us? 6, 36. Alright, so this has to be 36 degrees here. That's the exterior angle, 36 degrees. Is that exterior angle of the pentagon. So again, here you're going to go in a straight line, and you have to turn 36 degrees in order to stay on the polygon. Alright, so if we look at it from the exterior angle point of view, we are turning 36 degrees n times, and in order to get back to where we started, we have to go a full 360 degrees. So again, n is equal to 10. So we have a 10-sided polygon in the middle, which means that we have to have 10 pentagons around the outside to complete the circle. Alright, so 10 is the number of pentagons we need.